What's up, guys? It's Mr. Meehan. We're going to work through Unit 1, Lesson 1. We're going to be talking about properties of segments and angles and finding their measures. But first, we've got to talk about some definitions. So, first definition, it says a blank is a location that has no size. This is called a point. A point is a location that has no size. There's a lot of different ways to represent a point. Just kidding. No, there's not. There's only one way. That's a point right there, just a dot, right? You can call this point whatever you want. I'm going to call it point P. But say we wanted to call this point A, we could totally do that. Say we wanted to call this point dog, we could totally do that. We can call it whatever we want. It's just a point. I'm going to call it point P. If we wanted to write that out in a sentence, say we had, oh, here's point P, we would just write down point P. There we go. All right, the next definition. It says a blank is an infinite number of points on a straight path that extends in two opposite directions. This is called a line. A line is an infinite number of points on a straight path that extend in two opposite directions. So you can imagine that if we had a million or even a double million or a triple million, so many points right next to each other that they create a line. I mean, that's all it is. It's just so many points, an infinite number amount of points right next to each other. All right? To represent a line, what we do is we draw a line. I mean, just like that. The reason why we put the arrows on the end is to show that it goes on infinitely. All right, if we didn't have the arrows, then it would be a segment, and that's something we're going to talk about later. If we wanted to label this line, there's a couple different ways to do it. The first way is to pick 2 points on the line. Let's say we have point A and point M. Those are just 2 random points. It doesn't matter what points they are. Again, you could call those points whatever you wanted. But we have points A and M, so we could say that this is line AM. So we write AM and then put like a line on top of it. So something like that. You could call it that. Or say we just gave this line overall a name, like line L, like a cursive L. We'd call this line L. That's another way you could do it. Or if you wanted to call it like line dog, again, you could call it whatever you wanted. But oftentimes it's just kind of like a lowercase letter. So line L. The next one, it says a blank is an infinite number of points and lines on a flat surface that extends without end and has no thickness. This is called a plane. Oh, that's not the right spelling. Hang on. Plane. Like an airplane. Not really, though. A plane is an infinite number of points and lines on a flat surface that extends without end and has no thickness. The way we represent this is kind of just like a flat polygon. There's no good way to represent like a flat surface in 2D, so we just kind of draw a polygon. A plane is just a flat surface. So you can imagine like your desk that you're working on, flat surface, that's a plane. But this plane extends infinitely in all directions without end. It has no thickness. The way we can what we can label a plane as is we can pick 3 points on a plane. Let's say we pick X, Y, and Z. That's what we're going to call those points. And we can say that this is plane X, Y, Z. Or if you wanted to give this plane an overall name, just like we did with the line, where we called the line L, we could say like this is line, let's say W, or plane W, right? We could say that this is plane W. Either way works, right? Pretty cool. If you notice, to make a point, you need 1 point, obviously. To make a line, you need at least 2 points. And to make a plane, you need 3 points. So that's kind of interesting, right? This next one, it says a blank is the part of a line that consists of 2 points called endpoints and all points between them. So what this is a segment. All right. So it says we have 2 points and then all the points in between them. So we have kind of like a line in between 2 points, and this is a segment. So let's label these points. Let's say we have L and M, let's call it. All right. And we could say that this is segment LM, just like that. And instead of putting a line on top, we just kind of draw a little segment on top. So that way we know it's a segment, not a line. Or we could call it like segment LM. That's something else we could do, right? Whatever we wanted to do. All right, so this next one, it says a blank is the part of a line that consists of one endpoint and all the points of the line on one side of the endpoint. This is called a ray. A ray is part of a line that consists of one endpoint and all the points of the line on one side of the endpoint. What does this look like? We'll draw an endpoint. Let's label that R. And then let's have all the points on one side of it. So what we're doing is kind of drawing half of a line. So we're capturing all the points on, let's say, the right side of this point here, point R. And so we can say that that is ray. How could we call it? Let's say we have a second point, and we say that that second point is R and then P. So this is ray RP, and we draw a little like ray on top of that. So in order to write a ray, you still need 2 points. It's just that it only extends infinitely in one direction, and then it stops at one of the points on the other side, right? So that's what a ray is. A couple more. It says a blank is what's formed when 2 rays share an endpoint. This is called an angle. I'm sure you know what an angle is. All right? An angle is 2 rays, just kind of like that. And if we wanted to label this angle, we would still pick 2 points for each ray. So let's say we have point A, point B, and point C. So both of these rays share point B, and then they each specifically have A and C respectively, right? So we can say that this is angle ABC, or we can say that this is angle ABC like that. So we can draw kind of like a slanted L that kind of represents angle. So that way we know it's angle ABC. All right, then the last one, it says a postulate is something we assume to be true. This is called a postulate. It's just something we assume to be true. It's just like a statement that we just take as truth. There's no argument against it for us. Speaking of postulates, here's the ruler postulate. It says every point on a number line can be paired with a unique real number, which we call the coordinate of that point. Very simple idea. Don't overthink it. It says find the coordinates of point A and point B. I'm sure we can do that. What's the coordinate of point A? -3. What's the coordinate of point B? 2. Boom. We have mastered the ruler postulate. That's it. So 2 points are labeled on a number line. What are some methods for finding the distance between the points? Let's call these points, let's say y and x, just like that, okay? What are some methods for finding a distance between the 2 points? Well, what we could do, I think the easiest way is just to count. So we could go 1, 2, 3, 4, 5, 6, 7, 8, right? So counting, I'll say. Counting. All right, that's 1. A second way, let's see. What if we counted from 1 point to 0, and then counted from the other point to 0, and then added those up? So we would go 1, 2, 3 from the left side, that gets you to 0, and then 1, 2, 3, 4, 5 from the right side, and that gets you to 0, and then you could add those up. That could be number 2. All right, I don't know how to write that out. Let's say count to 0 from each point and add. All right. And then those are like the most basic methods, but what if you had numbers really, really far apart? That would be kind of hard to do, right? If we had 1 trillion on the left side, or -1 trillion, and then we have 1 quadruple billion, right? That'd be really hard to count. So the easiest thing we could do, maybe you noticed this, is to do, let's say, x minus y, the absolute value of x minus y. Or let's just say x minus y for now, just like that. So if we really did that, and we labeled that point x and labeled that point y, right? We would see that this is 5 minus -3. What is 5 minus -3? Well, that's 5 plus 3, so 8. And that's what we got earlier by counting. So we noticed that that works. All right? Yeah, I mean, it's pretty interesting. So let's move on. Let's look at this. It says the distance between 2 points on a number line. This is the absolute value. Let's see if I can spell it. Absolute value of the difference of the coordinates of the points. So the difference of the coordinates of the points is exactly kind of what we just did with the x minus y thing, right? So we did x minus y, and we found the difference of the coordinates is 8, all right? But why is it saying we want to do absolute value here? Because then it doesn't matter what order we subtract the points in, right? We could do x minus y, or we could do y minus x, as long as we took the absolute value. So if we look at this, right? Doing that same problem, Actually, let's do it down here. I guess it's the same thing, right? So y is at -3, x is at 5. If we did the absolute value of 5 minus 3, sorry, -3, we would get absolute value of 5 plus 3, which is the absolute value of 8. What's the absolute value of 8? I believe that's still 8 last time I checked. So that's that, right? But say we did the absolute value of y minus x, that's -3 minus 5. If we do this, then we're going to get the absolute value of -8. What's the absolute value of -8? Then we get 8. So because we put that absolute value there, it makes it so the order of subtraction doesn't matter. Let me write that down. Order of subtraction doesn't matter because of the absolute value. There we go. All right, so find the length of AB, BC, CD, and AD. If we wanted to find the length of a segment, if you have like a segment like this, where we have AB like that, the length is just represented by AB without the segment on top. All right, so if we wanted to find what AB was, there's a couple ways we could do it. We could say that this is either 12, the absolute value of 12 minus 5, it looks like, because B is 12 and A is 5, or this is equal to the same thing, so I really can write equal to the absolute value of 5 minus 12. Either way, you're going to get the same thing. You're going to get the same answer either way, right? So if we did the left side here, the absolute value of 12 minus 5, we're going to get absolute value of 7. If we did the right side, we're going to get absolute value of -7. All right? That means 7 equals 7. I mean, either way, you get the same answer, right? You get 7. So the distance between A and B is 7. Let's do BC. I'll do green. No, I'll keep it in blue. BC. Same thing. You can do it either way. I'm going to do it as 16 minus 12 here, and then I'll do the other two differently as well. So BC is C minus D, C minus B. I did 16 minus 12, the absolute value, which is really going to be the absolute value of 4. What's the absolute value of 4? It's just 4. Let's do CD. I just talked about how we don't need that up there when we're talking about length, but I put it there anyway. CD is, we did 16 minus 12 last time, so now let's do C minus D, which is 16 minus 21, right? The order doesn't matter because the absolute value. So it's really going to be the absolute value of 16 minus 21 is what? -5. So the absolute value of -5 is 5. All right. And then AD, let's do D is 21, A is 5. The absolute value of 21 minus 5 is the absolute value of 16. What's the absolute value of 16? I believe that's still just 16. There we go. Now here's a question. Does AB plus BC plus CD equal AD? I don't know. Let's figure it out. What's the length of AB? Well, that's 7, I think. What's the length of BC? 4. What's the length of CD? I think it's 5. And then supposedly, or it really is, AD is 16. So supposedly if this works, if AB plus BC plus CD equals AD, then this right side or left side should be 16, since the right side is 16, right? So let's add up the left side and see if we get 16 on both sides. So what's 7 plus 4? That's 11. What's 11 plus 5? That's 16. So 16 equals 16. So does AB plus BC plus CD equal AD? Yes, it does. So what this leads us to is the segment addition postulate. This says if points A, B, and C are on the same line with B between A and C, then AB plus BC equals AC. Makes sense, right? It's kind of like if we have a line right here, or let's say a line segment, right? We have A, point B, and point C, right? Then it makes it pretty obvious to say AB plus BC equals AC. The two smaller segments make up the larger segment. That's all that's saying. And we can use this in a lot of different problems, which I think is what we're about to do. It says, example, use the segment addition postulate to find the length of FH if we know F, G, and H are collinear. If you want to make a note of that, that means on the same line. And GH is 16. So it says GH is 16. It says all those points are on the same line. All right, and we're trying to find FH. There's a couple different ways we could do this. Let's just write down our segment addition postulate to begin. I think that's probably the best way to do it. So FG plus GH should equal FH. That's the segment addition postulate. And we can use that in a bunch of different ways, right? So let's write it, let's plug in our variables here too. So we can say 3x minus 1, which is FG, plus 2x plus 2, which is GH, is going to equal FH. The key ingredient to this problem right here is that GH equals 16. So that means this equals 16. It means 2x plus 2 is going to equal 16. And if we know that, then we can just solve for x, right? So we can say 2x equals 14, x equals 7, all right? And if x equals 7, skadoosh, we just plug it into our problem over here with our x's, right? So let's do it. So we can say 3 times 7 minus 1 plus 2 times 7 plus 2 equals FH. 3 times 7 is 21 minus 1 plus 2 times 7, which is 14, plus 2 equals FH. 21 minus 1 is 20. I'm going to kind of draw an arrow over to here. Let's see. 20 minus 1, or 21 minus 1 is 20, plus 14 plus 2 is 16 equals FH. 20 plus 16, that's 36, equals FH. So that's our final answer. 36 equals FH. So I think the best way to do any segment addition problem is to write out the segment addition postulate first, and from there then you can plug in the values that we know, even if they're variables, just plug them in, and then use the information that's given to you, which is what they gave us, all right? So points J, F, and L are collinear. That means they're on the same line, remember? It says if JL equals 25, what is N? So again, let's write out our segment addition postulate. It says JF is going to be, well, JF plus FL is going to be JL, right? JF plus FL equals JL. The two smaller segments make up the larger segment. So it says if JL is 25, what's N? Let's plug in what we know. We know JF is 3N. We know FL is 5N minus 7. And it tells us that JL is 25. So now we have an equation that we can solve for. We can solve N, solve for N. We can say that's 8N minus 7 equals 25. 8N equals 32. N equals 4. Boom. There we go. What about JK and KL? That shouldn't say JK, should it? That should say, instead of the K, what should it say? It should say JF and FL. That's what it should say. So what is JF? In order to figure that out, we just found out what N was. So let's plug in our 4 into both of these smaller equations here. So we can say JF is 3 times 4. What is 3 times 4? I believe that's 12. FL is supposed to be 5N minus 7, so 5 times 3, 5 times 4 minus 7, which is 5 times 4 is 20, 20 minus 7 is 13. There we go. So what we just learned about is the segment addition postulate, and very similarly to the segment addition postulate is the angle addition postulate, all right? It's just like the segment addition postulate, but now it's with angles, right? So it says a point D is in the interior of angle ABC. Let's break that down real quick. If point D is in the interior of ABC, what does the interior mean? Kind of like in the middle. In the middle. Kind of, right? Interior. So let's say we had angle ABC. That's what an angle looks like, what we just learned about earlier. There's A, there's C, there's B, A, B, C. And then it says point D is in the interior of ABC. So like right there, there's point D. And then let's say we can draw a line, a ray, I should say, between point B and point D. So now we have two different angles that make up a larger angle, right? We have ABD and DBC. So here it says a point D is in the interior of angle ABC. Then the measure of ABD, actually I'm going to write that, the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. So what does that mean? What is the M with the parentheses, with the angle sign? All right, all that means is when we're talking about the measure of something, we're really talking about how big something is in whatever unit that we're talking about. So if we're talking about the measure of like a segment length, we're usually talking about like inches or feet, something like that. When we're talking about the measure of angles, we're always 99% of the time talking about degrees. So, right? So when it says, for the first part here, it says the measure, the M represents measure. The measure of angle ABD, that's how big this angle is right here. So maybe it's like 19 degrees or something, right? The measure of ABD. So it's saying the measure of ABD plus the measure of DBC, so like this angle right here. So again, it's just some size in degrees, right? So if we have those two smaller angles added up, then that creates the larger angle, which, man, that doesn't look very good, but it's the larger angle, right? It makes the bigger ones, right? So the measure of ABC plus the measure of DBC equals the measure of ABC. Does that make sense? I hope it does. All right, example. It says if the measure of BAE equals 75 degrees, I'm going to write that in. BAE is 75. BAE is kind of like that larger angle. So I'm going to write like a big arc, a red arc, and off to the side here I'm going to put 75 degrees. And it says the measure of BAD is 54. BAD is 54. I'm going to put that another like a blue arc right there and say that that's 54 off to the side. All right. And then CAD is 21. Let's do that in green. I'll put a green arc and I'll say that's 21 degrees right there. Then what is the measure of BAC and DAE? Let's look at this. So we're trying to find, I'm going to write a question mark right here, and then DAE is a question mark right there, just so we know which ones we're talking about. All right, so here we go. Looking at this, it says, it looks like the measure of BAD, find those points, is 54 degrees, right? BAD is 54 degrees. BAD is really, I'm going to write this out, and it might kind of seem like a lot, but just try to follow it the best you can. So the measure of BAD, angle BAD, equals the sum of the two smaller parts that make it up. So you can see the measure of BAD is equal to the measure of BAC plus the measure of angle CAD, right? Those two smaller angles that make up BAC, when you add them together, they equal BAC, right? That's all that means. So let's see what we got. BAD is really 54 degrees. It told us that in the problem. All right, what else does it say? It says BAC we don't know, so we can leave that as the measure of BAC, angle BAC, plus the measure of CAD, which is 21 degrees. All right, so now we have 54 degrees equals the measure of BAC plus 21 degrees. So all you have to do is kind of imagine that this angle right here, the measure of angle BAC, is just like a variable, just like you would say like with X or Y or any problem where we use a variable, right? So we just solve for the variable. So what's 54 minus 21 on each side? We just do 54 minus 21, which is, let's see, 33 degrees, I believe. So the measure of angle BAC is 33 degrees. That's the entire problem. It's not that tricky, I don't think. It's exactly like the segment addition postulate. It's just with angles. So let's erase this question mark and put 33 degrees. All right, so let's see here. It says find DAE. All right, well, how could we do that? Well, I see that the red angle, right, BAE, is 75 degrees, and the larger angle BAD, the light blue angle, is 54 degrees. So if we did the measure of angle BAE equals the measure of angle BAD, I believe, plus the measure of angle DAE. That should be like the equation that we set it up, right? So all that's really saying is 75 degrees equals, is 75 is what they told us in the problem. That's where I'm getting that. BAD is really 54 degrees. That's what they told us in the problem. Plus the measure of DAE. DAE we don't know. The measure of angle DAE. So again, all we do is solve for the variable. And in this problem, the variable is the measure of DAE, right? So 75 minus 54, what is that? That's 40, no, not 40. 30, no, not 30. 21. 21 degrees is the measure of angle DAE. That's the entire problem. All right? So writing it out, it may seem kind of confusing, but really I'm just writing out an equation, plugging in the stuff that we know, and then just solving for the variable that we have to solve for. All right? A couple more things real quick. It says segments that have the same length are called congruent segments. Congruent segments. Congruent means the same, right? So whenever you're talking about, let's say, measurements, right? We're talking about lengths of things, size of things. You would say things are equal to each other, like 7 is equal to 7, 10 is equal to 10. This is equal to that. That's when we're talking about like measurements and stuff. Whenever we're talking about like objects or shapes or just segments or things in general, we would and they're the same thing, that means they're congruent. So we could say like this thing is the same thing as this thing, so that means they're congruent. So whenever we're not talking about measurement, but we are talking about the same things, same type of things, then we say congruent. So let's say we wanted to say this segment or this line. No, let's say this segment. That segment, let's say, is congruent to this segment. Actually, let's label these. Let's say XY and AB. If we wanted to say XY is congruent to AB, what we would do is we would put a hash mark just like that. And so for each hash mark, that's how we know they're congruent. So here, both of those have one hash mark. So we can say XY is congruent to AB. So that says segment XY is congruent to segment AB. The congruent symbol is the thing in the middle. That's this thing right here. It's an equal sign with a little squiggly on top. That means congruent. Say we had more than 2 pairs of line segments that were congruent. Say we had, now we have L and M, we have Q and P. Here, we can't use one hash mark anymore because these 2 segments aren't congruent to the other ones. We want to say they're congruent to themselves, but not the other line segments. So here, we're going to use 2 hash marks. And now we can say LM is congruent to QP, but they're not congruent to X, Y, and AB, all right? Cool. Similarly, we can kind of do the same thing with angles. We can say that angles that have the same measures are called congruent angles. Congruent angles, right? So if we had angle ABC, and we had angle, let's say, X, Y, Z. Sorry for the bad drawing there. If we wanted to say these angles were congruent, we can't really put hash marks, right? Because then we're talking about the lines or the segments, the rays, right? So we put these arcs on the angles right there. And so one arc and one arc, that means those angles are congruent. So we would say angle ABC is congruent to angle XYZ. There we go. If we had more than 2 pairs of angles and we wanted to represent that 2 of them were congruent and then 2 of them were congruent again, let's say we have a second pair of angles. This angle is called JKL. This angle is called, let's see, What haven't I used? MOP. If we had more than 2 angles, again, we can't use just one arc this time because we don't want it to be congruent to the other ones, but we can use 2. Or if we had 3 pairs, then we would use 3, right? So you just keep adding them and keep adding them. All right. So this problem here says the measure of XWZ is 127 degrees. XWZ is this largest angle right here. I'm going to write that off to the side. So it's that red arc, and it's 127 degrees. It also says the measure of YWX is 32 degrees. Find the measure of YWV. So I'm going to kind of erase my arc for now to not get confused. But here you can see that we have a hash mark right there and a hash mark right there. What we just talked about right up here says that if we have 2 angles that have 1 hash mark and 1 hash mark, those angles are congruent. So what we can say is that angle VWZ is also 32 degrees, right? And then if we're trying to find YWV, it looks like, there's a couple things we can do. Actually, I think there's only one way to do it. We could say the measure of angle XWZ, which is the largest angle, is going to equal the sum of the measure of angle XWY plus the measure of angle YWV plus the measure of angle VWZ. So all I said is the larger angle equals the sum of all 3 of the smaller angles. And if I wanted to plug in those values, we totally could. XWZ is 127 degrees, it told us. It also told us that XWY is 32 degrees, plus our variable now, which is the measure of angle YWV, and then plus 32 degrees again. All right? And then we just solve for our variable. So subtract 32 degrees and 32 degrees on each side. And once we do that, what's 127 minus 64 is, all right, it's 63. Had to double check. So our final answer here is 63 degrees equals the measure of angle YWV. That's the final answer.